Here we're looking at algebraic expressions raised to fractional exponents. We have to use all of our knowledge of properties of exponents and mix that up with what we know about how fractional exponents work. But if you can tackle the two pieces separately, this won't be a problem. Let's start with this guy. There will always be different ways to approach problems like this. I'm going to start by looking at the inside of the brackets and seeing whether I can simplify. I have a value, an 8, a b, and a c, one instance of each. So there's nothing huge I can do here, but I do notice that I've got a b raised to a negative exponent, so I'm going to resolve that first. So the 8 and the c to the power of 3 are going to stay in the numerator, but because b is raised to the power of negative 6, b to the power of positive 6 will end up in the denominator. All of that is still raised to the power of 2/3. Now I recall that every single thing inside the brackets must be raised to the exponent on the outside of the brackets. So I'll take the 8 and raise it to the 2/3, the c cubed and raise it to the 2/3, and of course the b to the power of 6 as well. What does that look like? Well, I've got 8 to the power of 2/3, c cubed to the power of 2/3, and in the denominator, b to the power of 6 to the 2/3. Now here I'm going to treat numbers a little bit differently from variables. Any number raised to a fractional exponent, I'm going to see if I can evaluate it. Otherwise, I will just have to leave it as a fraction, but it's possible that I can keep going here. In terms of any letters, here I'm going to apply the property of exponents that says if I've got a base, like the c, raised to an exponent that's raised to an additional exponent, what I need to do is take the two exponents and multiply them together. So that happens in the denominator as well. All right, so we've got 8 to the power of 2/3. As we said, this is the one I'm going to try to evaluate. So this is asking for the cubed root of 8 raised to the power of 2. Because 8 is a perfect cube, this will work just fine. C to the power of 3 to the power of 2/3 is really asking me to take 3 and multiply it by 2/3. Multiplying those fractions gives me 6/3 or just 2. Or maybe you've noticed that because I have a 3 in the numerator and in the denominator of two fractions that I'm multiplying, that the answer must be 2. Either way, I'm left with c squared. Similarly, in the denominator, I have 6 times the power of 2/3. So the 6 and the 3 will cancel. 6 divided by 3 is 2, and my answer is 4. Or 6 times 2/3 would, of course, be 12 over 3, which is still 4. So my denominator is b to the power of 4. Now finally, let's evaluate the cubed root of 8 squared. The cubed root of 8 is 2, and 2 squared is 4, so my final answer is 4 c squared over b to the power of 4. The next question to the right here is very similar. Again, I'm going to look inside the brackets and determine whether or not I can simplify. Here, there's nothing I can do. So my next step really is to take everything, the 32, the x to the power of 5, and the y to the power of 10, and raise it to the 1/5. So we have 32 to the 1/5, x to the power of 5 to the 1/5, and y to the power of 10, also to the 1/5. Once again, if I can evaluate the numbers, I will. So this is asking for the 5th root of 32, and 32 is a perfect 5th, so this will work. And now I'll apply the properties of exponents for the variables. X to the power of 5 further raised to the 1/5 is x to the power of 5 times 1/5, and 5 times 1/5 is just 1. Y to the power of 10 further raised to the 1/5 is y to the power of 10 times 1/5, and 10 times 1/5 is 2. So that simplified quite a bit from the original expression. And then finally, the 5th root of 32 is 2. So the final answer is 2 times x times y squared. With that, let's move clockwise and try the expression on the bottom right. Remember what I suggested as my first instruction? Have a look inside those brackets and see if you can simplify. Particularly for these questions where I've got fractional exponents. If I can simplify what's going on inside the radicals, or inside the brackets, that's going to help me a whole lot. 27 and 64, well, those don't have any common factors. So 27 and 64 can't be simplified. But I have an x in the numerator and 4 x's in the denominator, so I will certainly simplify that. I can think of that as x to the power of 1 over x to the power of 4, giving me x to the power of 1 minus 4, which is x to the power of negative 3, which means I have 3 x's in the denominator. Or I can think of this as removing 1x from the numerator and 1 from the denominator. In any case, I'm left with 27 in the numerator and 64x cubed in the denominator. And all of that is still raised to the power of 2/3. All right, every single thing inside the exponents, the 27, the 64, and the x cubed must be raised to the 2/3. So we have 27 to the 2/3, all over 64 to the 2/3, and x cubed to the 2/3. We've done this before. If I've got a number, I am going to try to evaluate it. So here we have the cubed root of 27 raised to the power of 2. Great, 27 is a perfect cube. Divided by the cubed root of 64, also raised to the power of 2. And finally, x cubed to the power of 2/3 is x to the power of 3 times 2/3, which turns out to be x squared. The cubed root of 27 is 3. 3 to the power of 2 is 9. The cubed root of 64 is 4. 4 to the power of 2 is 16. So my final answer is 9 over 16 times x squared. Last one. This one looks a whole lot worse than it is. And the reason I did the one on the right first is because we can help ourselves a whole bunch by looking inside those brackets and simplifying first. Here we absolutely need to use our properties of exponents because I don't know how to write a 5/7. So we can't visualize this quite the same way, but inside of these brackets, our properties of exponents are easy to use. A to the power of 5/7 divided by a to the power of 2/7 will be a to the power of 5/7 minus 2/7. So this is just the inside of those brackets, and 7/4 remains on the outside. 5/7 minus 2/7, well, they even have the same denominator, so the subtraction is relatively straightforward. 5 minus 2 is 3, so inside these brackets, we have a to the power of 3/7. We're still raising that to the power of 7/4. And then finally, these numbers work out very well. A to the power of 3/7 further raised to the 7/4 means we're going to take these two fractions and multiply them together. You can think of that again as 3/7 times 7/4 will give you 21/28, which simplifies to 3/4, or recognize that the 7s will cancel. In any case, the final answer is a to the power of 3/4.